Hey everyone, thank you so much for being here. I'm going to share my screen.
Hello.
Hey,
Well,
how's it going?
I'm supposed to introduce you.
Oh, do it, do it.
Sorry, I should have told. Well, I said this is Alan Greenspoon. I hope I pronounced it right. You're going to say how to build a cloud-connected AR app in 50 minutes. What are you going to do the other 25 minutes?
Um, basically showcase a lot of demos and showcase how to do that multiple times on multiple platforms. It's going to be a lot of fun.
Oh, great. Well, I will leave you to that. Then we can maybe talk later in the Q&A. Good luck.
Appreciate it. Thank you so much.
That's not correct.
Perfect. Thank you so much, Jost. Hey, everyone. Today we're going to talk about augmented reality, virtual reality, and how you can build a cloud-connected app in 15 minutes or less. I'm Alon, founder of Echo AR. We're a cloud company based in New York. We basically provide tools and network infrastructure for developers and creators to build AR, VR applications at scale. And today we're going to see how. So I'm going to start by saying hello. I'm Alon, founder of Echo AR. I did my master's of computer science at Columbia University, specializing in augmented and virtual reality, and did my undergrad in computer science, electrical engineering. So a certified nerd and a big believer in the AR VR space. Now, before we start, this is obviously a room of kind of experts, but let's kind of level set. Let's define these terms together because we're going to obviously use them a lot during this talk. So virtual reality or VR is when everything around you is digital. You're fully immersed in a 3D environment. And basically everything you see is some kind of computer-generated image or CGI, a construct that is being kind of projected into your eyes through a headset. That headset includes everything you see and sometimes control what you can hear, and you're using controllers or your hands to kind of interact with it, as opposed to augmented reality or AR, in which we have the real world still visible to us, and we're basically kind of looking at the world through some optical see-through like glasses or a headset, or in camera see-through like a phone or a camera on an iPad. The world is being overlaid with digital content, but basically we still kind of see the real world. A really cool way to understand this is the amazing movie Space Jam, in which we have Michael Jordan being teleported into Looney Town. Everything around him is digital. He's fully immersed in this cartoonish environment, and basically everything he sees is kind of this, again, computer-generated image. He's interacting with bugs and the other Looney Tunes in a completely cartoonish environment, as opposed to what we have later in the movie, in which we have Looney Tunes coming to us, interacting with Jordan, Bill Murray, playing basketball together on the real court. So this is basically kind of the comical way to understand AR versus VR. Either we are being teleported into Looney Town, or Looney Town is being teleported to our world. It's a super kind of interesting way to understand it. Some real world examples of that is something that we've all known and love, like Pokemon Go, and people are running around interacting with digital monsters that are not actually there. Or something like Beat Saber, when we have people slashing cubes based on the rhythm of the music, and basically kind of being kind of interacting with content in a kind of fully digital, fully immersive world, as opposed to interacting with kind of monsters in the real world. Now, another example of this technology is something that is really close to my heart, and the pun is definitely intended. This is my thesis project back at Columbia University. We took CT and MRI, converted into 3D, and then basically put this on the HoloLens, a kind of headset by Microsoft, for a physician to see the inside of the patient in real time. It was an amazing use case of augmented reality, an amazing kind of way to bring AR into the OR. The physician basically get this kind of 3D reference map of the patient's anatomy in real time, allowing them to kind of understand how to operate and do the surgery and kind of improve the patient outcome. I would personally scrub into surgery. It was an amazing experience. I scrubbed into more of a dozen surgeries that, again, basically took those 2D scans, converted them to 3D models, and put them on the headset. But in order to achieve that, in order to kind of create that experience, I had to do something that I really, really hate. And that's waking up early in the morning. I had to be in the hospital at 6 a.m., take those 2D scans, make sure to convert them to 3D models, deploy them to the headset, and then kind of have that headset be ready for the physician to work with. And that process was so frustrating and took so much time. And for me as a developer, I only wanted to do two things. I wanted to manage 3D data and deliver it to a near device. Because if you think about it, for me, that experience always looks the same. You just replace a heart with an aorta, or one patient's heart with another, and the application itself doesn't really have to change. It's just the content that needs to be updated. And that shouldn't be the role of a developer. So for me, it was, again, all I wanted to do is just manage and deliver content. And when talking to other developers building augmented virtual reality applications for healthcare and retail and data navigation and visualization and games, they basically all said the same thing, that there's no easy way to manage and deliver 3D content. But if you think about it, this problem was already solved for 2D data. If you're building a website, you can use something like Heroku as your cloud platform to kind of update your function remotely. If you're building a mobile app, you can use something like Parse or Firebase to kind of use as your backend as a service for your application. So we went from web to mobile to now this new type of technology, which is AR, VR, immersive, XR, MR, call it whatever. And the question has to be asked, who's going to build the same kind of cloud platform for this new type of content? And you've guessed it, this is what we do at Echo AR, where, again, this cloud platform for augmented virtual reality, basically providing tools and network infrastructure for developers and creators to build 3D applications. And today we're going to see how you can use that to build applications really, really quickly. But before we start, let's kind of see how that works. So the same way you don't need to be a web developer to kind of update a blog post, you can drag and drop an image or video, suddenly that appears on web and mobile. Or if I'm in New York and you're in California and we're both watching an episode on Netflix, we automatically get the best streaming experience. So we translated these concepts into augmented virtual reality, basically providing a way to manage and deliver 3D data and get the best 3D streaming experience. And the way it works is really interesting because if you think about it, you as the user, you can't move an image or a video on a website. But you can definitely move a 3D couch across the room, and that needs to be updated on the cloud. I'm being told I have mic issues. It might be the computer. I'll try. Let's see if this is better. Is this mic better? Hopefully. I'll assume yes. So basically allow you to kind of switch and kind of manage content remotely. And again, the interesting part is the connection between the 2D, the 3D content and the real world targets. So this is basically what we've built, is kind of a content management system and delivery network specifically for 3D that kind of knows how to handle 3D models and animations and content really, really well. You can register on our website, and now I'm going to show you how to kind of build applications using our tool, and basically kind of build an application at scale. So once you go to our website, you can register for free to basically kind of get an API key, a project key to build applications with. Once you get that key, you're going to get access to our console. So this is what you see on the screen right now. On the left, you see the console. This is my API key after I registered. That's what I got. And on the right, you just see my phone. And I'm going to start with something super, super simple. I'm going to add some content to the cloud. So let's see how that works. So I can do add to cloud, and then I'm going to be able to either add my own files, like it's videos, images, 3D models, or also kind of use the search engine that we have to kind of grab 3D models from content aggregators out there. You can search for anything you want, and automatically you'll have kind of the 3D model to kind of import into your project. So I'm going to start with something simple. I'm going to throw in this Empire State Building. It's a 3D model, again, pretty suited for 3D printing. We're posting it to our cloud. What happens right now is that we take that 3D model, we convert it so it'll work on Android or iOS or MagicLeap and all the different platforms out there. Once that's done, we're able to kind of see the 3D model here. But what I'm going to do right now is I'm going to open a sample app that we have right here. We have all these different SDKs or different platforms that you can download, and some sample apps that I'm going to use right now. You can open a sample app. This is an example for an Android app. I'm going to plug in my API key in the app. It will stream the data from the cloud to the device. Obviously, most developers have their own app. This is just a sample. Now you can see my apartment. The camera recognizes the floor, and there you go. The Empire State is here with me, and I can walk around it, walk inside. Super, super simple. What happens if I want to change this to something else? Instead of seeing the Empire State Building, let's say I want to publish new content. So instead of rebuilding the application or doing anything technical, I'm going to go back here. I'm going to delete the previous entry. I'm going to upload something else, and that will automatically kind of update across all platforms. So I'm going to throw that in. Let's say I want this building instead. Same process occurs. We're taking that 3D model, converting it to work on Android and iOS and MagicLeap. Once that is done, we can open the exact same app, again available here, plugging in our API key. So let's do that. Data, again, will stream from the cloud to the device. So the app itself is super, super small. There's nothing there except for camera. Camera recognizes the floor, and there you go. Suddenly we're able to see kind of the building change automatically. But what happens if, okay, so this is a native mobile example, but for example, we work with companies in the art agency space. They wanted to have random people walk into an art gallery, open a phone, and suddenly see things in AR without doing anything technical, without even installing an app. So we also support WebAR. So again, because we're a cloud, it doesn't matter which camera you're going to use. So if you want, you can scan this QR code. I'm going to do it right now, but you can see, if you see the screen, you can scan that as well. And that building will actually stream to your phone right now. And you can see that in your apartments without installing anything. So this is support for WebAR. And again, that's the quick and easy way to build an application. You just drag, drop the model, automatically you have a WebAR generated experience. So all you have to do is scan this QR code. There you go. I'm going to see this through a web browser. I don't have to install anything. I'm going to do see in AR. Automatically, the camera will instantiate. You see my apartment again, and there you go. You see that building right here, and I'm able to kind of place it in my room through web. And again, you don't have to kind of install anything. Super, super simple. So we saw web, we saw mobile. And another example that I want to show you is Unity. It's a game engine a lot of developers love to use, and later we're also going to kind of dive into Unity and build an app together in Unity. But this, again, just to show how we can, from the cloud, stream to all these different platforms. It's web, mobile, Unity, or whatnot. So here's Unity. Again, camera recognizes the floor, no surprises there. We see the building, no surprises there. What happens if I want to change something in real time? So let's say I want this to animate or do something kind of out of the ordinary. So I can click this button, go to the data panel, and add stuff. So for example, let's say I want to make it rotate. So I'm going to add some metadata. I'm going to say direction equals right. Bam, suddenly it starts to rotate in real time. Let's say I want this to be a little bigger. So I can do scale equals 2. Voila, suddenly it pops up. So these are obviously simple examples, but they're to show how your kind of app is connected to the cloud in real time. Every change you push kind of pushes notifications directly to the application, directly to the content that you have, and things can literally change automatically just because you click a few buttons remotely. So this is a really powerful example, again, to show the power of the cloud, how you can kind of publish things to your application in AR without doing anything. So we saw web, we saw mobile, we saw Unity. Now I'm going to show another example, because everything we saw so far was kind of based on on surface detection. The camera recognizes the floor and overlay data on that. Another technology that we support is image recognition. The camera recognizes an image and then overlaying the content on top of that. So if I scan this QR code, and again, you can do the same with me, and kind of scan the QR code with your phone, you will be redirected to a website. You don't have to do anything technical for that. And then there you go. Suddenly we see that building kind of overlay the image as opposed to what we had earlier, overlaying the floor. Super simple example. This doesn't have to be a QR code. It could be any image that you want, and I'm going to show you in a sec how that works. But basically, this is another way to show you how you can, like, again, build an application really, really quickly, upload an image, upload some content, and there you go. You have a web AR generated experience. So let's see how that works. So maybe I'll add some new types of content. Let's add a video instead of a 3D model. There you go. And here, let's choose on an image as opposed to anywhere. And I'm going to plug in some image right here. So let's do that. Same process occurs. We're uploading the content to the cloud. It's being converted now. Instead of a 3D model, it's going to convert images and videos. They're going to be optimized for AR specifically. Maybe I'm also going to add some content in a specific location. We basically allow you to we support geotagging, so you can kind of add, let's say, a 3D model in New York. If you open the app in New York, it's going to show you the Empire State Building. If you open it in San Francisco, it's going to be the Golden Gate Bridge. So there you go, uploading to our cloud. Super simple. And again, you can see like all the content is there, and kind of you're able to manage it. So let's see the image right here. So if I scan this now for the video, again, redirects to a website. I don't have to do anything technical. But now, instead of using the QR code as my target, I need to use the image. So if I place my phone in front of the original image that I just uploaded, the camera will kind of recognize the image. And there you go. We see the video. I'm going to scale it with my fingers a little bit, and I can press play. Super simple, and again, shows you image recognition on web without installing anything. All you have to do is just drag and drop something to the console. Super, super simple. Perfect. So we saw web, we saw mobile, we saw Unity, we saw how you can switch between the platforms. We saw how data is being streamed to all of them in real time. What else can we do? So you can obviously switch a theme, which is cool, dark being the default. You can access all our SDKs right here, so the sample apps and all the kind of different SDKs allow you to build applications, if it's for Unity or Flutter or Swift or Java or whatnot. We have a bunch of code examples we're going to see in a sec. But let's talk about resources. So we have the documentation here that kind of goes through everything I showed so far with GIFs, like kind of line by line, how to kind of do everything, how to share 3D models, how to kind of build your application. Our GitHub page is filled with like amazing open source examples that people can use. So for example, I'm going to open a few of them just to kind of share what you can build. But basically, we have some really cool examples here. Let's open some of them. There we go. Let's do this one. Let's do this one as well. So what do we have here? So we have like a bunch of examples of like things that you can kind of create. For example, here's a timely one around the election. You drag and drop images, videos, 2D models, and there you go. You get this kind of AR app automatically that you can build. Super, super simple. All you have to do is update content, update some metadata, and there you go. You have an experience. Same thing happens, I don't know, if you want to do a living room inside a living room, binge watch your movie inside a 3D space. Super, super simple. Another example I can show is face swap. You want to have like face filter, upload a new face, automatically that streams to the app, and you can kind of control the content remotely. This is a COVID-19 visualizer. Later, we're going to build that together in Unity, so stick around. Another example from our work, you can place 3D models, text, and again, just control everything remotely. Here we have an example of image recognition. We can kind of bring images to life super, super simply. We're just kind of throwing in images and videos, and matching them with like specific targets. And the other stuff is you can just register to our kind of developer Slack and kind of ask questions from our support team or reach us or send us a tweet. Other things that you can do in the console, so we saw already how you can manage data. So not only that you can manage data per 3D model, you can also manage data across all your platform. For example, we worked with a company that did a scavenger hunt, kind of murder mystery game in AR, and they had different kind of 3D models associated with different scenes, but they also had this database for like all the kind of all the data in the platform. You can manage your subscription, see how much bandwidth you're using, how much storage, how many API calls you're making. Manage the distribution of your content around the world. So remember, we added kind of the Fox in New York. So there we go. We see the servers that are kind of supporting your application. We can see the security features and the team members that you can add to your kind of application for them to collaborate with you. And the insights page, you see some really valuable data on your application. So we just saw like the kind of the building being streamed. So we streamed that. That is the most popular model that we have. From all of the models that we have, we can see a spike in usage. So again, really, really kind of easy to kind of monitor your app and the kind of usage of your project in augmented reality. You can see the distribution of users that you have around the world. See some really cool tutorials on how to kind of build your application or have some frequently asked questions. There's a bunch of examples here that, again, totally open source. You can just grab and play around with. And they're all kind of open source for you to kind of start your application really quickly. And the inspiration page, which is my favorite page, that has so many cool examples of AR, VR, and some of them are powered by Echo AR, like the art installation that I mentioned, or the murder mystery game, or a cool project that we did for Verizon 5G. There's so many really cool examples here of AR and VR for healthcare and data navigation and military use and retail and shopping, and even COVID-19. Recently, a lot of people kind of submitted projects around that, like this COVID kind of spread visualizer in VR that kind of shows how long COVID lingers in different spaces and different surfaces, or a COVID tracker that people will kind of scan QR codes, see informational data on COVID, but under the hood, it actually kind of accumulates how many people scan this to enforce social distancing. The really cool project with Unity, image detection, surface recognition, really, really cool stuff like a mask visualizer. Really check out like all these really cool things that you can do with Echo AR. And all you have to do is like, you can build an app and then control that remotely through the console. So definitely check it out and get inspired. Really looking forward to see what you can build, and I'm going to share with us so we kind of feature you and allow you to kind of expand your reach. Okay, so now that we've seen a lot of non-technical things that you can do and how to build an application, we're going to get web working and mobile and Unity. Now we're going to do a more technical part of the workshop in which we're going to talk more about how to build an app with Unity and our SDK, and this will be a little more technical. So this is Unity. It's a game engine a lot of developers love to use. You can kind of download our SDK right here in the downloads page. You just click that, you download the SDK, and then you double click that to embed that into Unity. Unity is a really kind of nifty and very popular game engine, definitely in the AR VR crowd, because it's used to build a lot of AR VR applications. We have a partnership in Unity to basically kind of make sure our SDK works across all the kind of releases. Once you have that, once you embed the Echo AR SDK, you're going to have this empty scene. You have the Echo AR folder with this kind of sample scene. Again, this is an empty scene. There's nothing here except for our kind of SDK. If I plug in my API key right here and press play, this empty scene will start to populate with content from the console. So suddenly we see the building right here. We see the video. Maybe I'll delete the video because it's playing in my ear. But then there you go. The video, once it's deleted from the console, will automatically be deleted from the game engine. The fox is being occluded from the by the building. So let's move it a little bit. We already know how to do that. So let's do that. Bam. So you can see again that like what we have here is this kind of real-time backend that you can like throw in content, automatically it appears in Unity, automatically it's being affected by everything you do in real time. If I stop Unity from playing, everything disappears. So data doesn't actually persist in your application like we talked about. Everything kind of is being cleared. Your app is super, super small, which means the content, again, is not preloaded, and you can kind of load that only on the fly. If I play the scene again, data, again, will come from the cloud to the game engine, and voila. And we can see what's really interesting here is how the scene was kind of reconstructed. The building is still rotating. The fox is 10 feet away from the building. So what we have here is what we call a stateful content management system that remembers the state of your scene and kind of recreates it on load. And again, we can kind of, if I delete things or change things kind of go back automatically. If I move the fox back to the center, there you go, it's going to jump back. Okay, so we saw how you can stream data and we saw how you can like play around with it. Now let's add some changes. Let's do some changes. Let's play around with it. So what's cool about Echo AR is that every 3D model, every 3D asset has a custom behavior script attached to it. This is a script that you can change that will basically allow you to kind of change the way the 3D model or the video is kind of used. Oh, we have a question in the chat. How can we create an AR cloud application using Unity and Firebase such that we can load 3D models from cloud? So this is exactly what I'm showing right now. So perfect question. So basically, again, all we have to do is just embed our SDK into a Unity project, and the minute you press play, data will stream from the cloud to the device. Super simple. So this is the custom behavior script. It's a Unity script in C#. A C# script in Unity format, to be exact. If you know C#, perfect. If you know Java or any other object-oriented language, you're also good. What we're going to see right here is basically how you can change things and add functionality. So we have two main functions here. One is the start function, evident by its name, happens when you start the application. And we also have the update function, which is a really interesting function that actually kind of executes every single frame. So remember, you're coding in 3D now. There's a scene being rendered. There's like a video running on your phone. And that means that like every single frame, you can kind of run this function to do something. But here you have to kind of remember your CS fundamentals, because if this function gets stuck or hangs, your entire application will get stuck or kind of will hang. So let's start with something simple. Here we have the start function, basically in the beginning adding some script to our object, and then asking something from the cloud. Let's see what we have here. We're saying, do I have any additional data? If I do I have an additional data called name? If that's the case, set the name of the object to that name. Super, super simple. So now we don't have a name, so maybe let's add it. So now if I play, I can see that the name of the fox is Arctic Fox. But now I can add a name to it. So this is free text like we saw earlier. We can add whatever we want. So let's do name and then call the fox, let's call it Kevin. Now when I press play, data will stream from the cloud to the device, but also send that kind of script to be instantiated. And then we see, there you go, the name of the fox is now Kevin. Super simple. So this is, again, a simple example, but it's to show that you can send data from the cloud to the game engine. You can have that data be used to whatever you want, enable or disable if flows, control features. If I change the name from Kevin to, let's say, Sam, nothing happens. Why is that? Because the snippet of code that kind of handles that feature of naming is in the start function. If we want it to happen every single frame, we have to, as you guessed it probably, move this snippet of code from the start function to the update function. And now when we restart the application, now every single frame we're going to ask, do I have any additional data? If so, get that name, if it exists, and then set the name of the object to that name. So let's see how that works. So now we have Sam the Fox. And now if I change something here, like set it back to Kevin, bam, automatically it changes to Kevin. So this is, again, a simple example, but that you can choose any data that you want. You can put any kind of content that you want. That means that you can kind of, and again, disable or enable features remotely, add any features that you want, control it remotely, disable things remotely. And again, all through the power of the cloud. And again, when you close the application, everything kind of disappears. So this was a quick and simple example. Now we're going to transition into a more complex example, building a kind of more robust application. So I'm going to upload new content. I'm going to upload that through local storage now. So let's see how that works. I'm going to throw in this 3D model of Earth, and I'm also going to add this Excel file, basically a CSV file that has all these keys and values. So I want our system to kind of preload them, so I don't have to kind of manually code them. So there you go, like all these keys and values. Plugging that in, same process occurs, uploading to the cloud. Now we're just going to add the extra parsing of metadata. I'm also going to swap the custom behavior script under the hood, and now we're going to have a more robust script that we can review together. So let me overwrite that, and let's review the script together. So there you go. So now this is our script. Let's kind of review the changes together. So what do we have here? So we have an array of continents. We have some dictionaries, some data structures. The start function looks exactly the same. Oh, there you go. Our Earth is right here. And if we kind of look at the back, we can see all these kind of metadata already preloaded. This is perfect. And now the update function is much more interesting. Let's see what we have here. So we're asking, do I have any additional data? If so, do I have a scale? If that's the case, we're going to parse that scale into an integer. We're basically going to save that as a number. After that, we're going to kind of go over all the continents, and we're going to ask, do I have a data entry for that continent? If I do and I have a graph for it, let's parse the number that is associated with the continent to the number of cases of COVID, let's say, in that continent. Now, after that, we can say, okay, so if I have a graph, let's set that size of the graph to the number of cases. If we don't have a graph, let's create one. Let's create a cylinder, give it a color, give it a name, give it a location, give it a size based on the number of cases, maybe add text to it. And if we don't have data, let's just delete the graph. So let's see how that works when we press play. So we're going to press play. Data will stream from the cloud to the device, and we're going to see how the data is being used. So there you go. Voila. We see this Earth spinning, and we see all these graphs that we kind of interact with and see that are all kind of generated from the data that we have here. And now if we change that data, let's say I make Antarctica from 1 to 8, bam, suddenly that graph kind of jumps in real time. This is, again, a really quick and easy way for you to build applications and kind of manage the data remotely. If I delete Antarctica, bam, automatically it deletes itself. So super, super simple. And again, a really cool way for you to build an application. As I mentioned, this code repo is totally open source. It's on our GitHub page. You can use that to kind of automatically start your application. Just take that open source code, throw the models in the console, and you're good to go. Perfect. So let's recap here. So we saw how you can build applications on the web, on mobile, in Unity. We did a deep dive into Unity and how to kind of build an application on the game engine and how you can kind of add data in real time. Now we're going to go back to the slides and kind of recap some of these things and discuss a little more. So just remember to kind of go to our website to kind of recreate everything I just did. So what do we see so far? So developers can choose any platform. If it's Android, iOS, web, Unity, you name it. Content creators need no technical skills. Everything we did in the beginning of the workshop was very kind of non-technical, then super simple. And then we build, store, and deliver all that content to devices everywhere. And it could be any device out there. You as a developer, you obviously save time and money in building applications, and content creators need no technical skills to build applications like we saw, and companies to literally send data all over the world, like the companies that we're engaged with are basically kind of delivering data everywhere. We talked about use cases like surgery and ads and tourism and shopping and retail, and we saw the inspiration page that is filled with amazing examples of AR and VR and things that you can build in real time and recreate them. We saw our GitHub page is filled with open source examples that you can literally use right now to build applications with. And again, those applications will be cloud connected. A little bit more about us as a company. We won a bunch of awards and we're backed by some of the most amazing investors in the country, like Imagine Ventures and Techstars and Verizon. And we're featuring all these major events. And hopefully when things go back to normal, this event was obviously amazing, but once things go back to normal and we have physical events, make sure to say hello to our team as well. We love to say that we power applications across all platforms, so definitely kind of try playing around with AR, do the web application, do the mobile application, do the Unity application to kind of get a sense of what you can build across platforms. Make sure, again, you register for your API key to kind of start building, and because I'm really kind of excited to see where you're going to build, and then we can also feature you in the inspiration page as well. Thank you so much for being in this workshop. We're a little kind of quick on time. There weren't a lot of questions, but if you have any questions, feel free to kind of write them in the chat and I'll be happy to answer. And if not, stay safe, healthy, and sane during these weird times. And thank you so much for being in this workshop. Really appreciate your time. And again, this is definitely kind of the time to build applications, specifically AR and VR ones. What we do right now is a new normal, like 2D interactions and like kind of talking to people through web. And everyone's like looking to the next thing. And the next thing is definitely 3D, is definitely AR, VR, XR. So start building amazing things. My email is right here if anyone wants to kind of reach out. Thank you again so much for being here and have an amazing, amazing weekend. And thank you, Joseph, for kind of moderating. Really appreciate it. Oh, I think you're muted.
Yes, I have a hard mic to prevent me from talking nonsense while I'm watching your stream. I think I can speak for myself that it was like standing in a hurricane. you unleash an amazing amount of information in about 35 minutes. I'm really impressed. But before we go in the questions I actually have, because I'm more interested in more than just interested. I'm also interested in a professional way, but we'll maybe do that later. There are actually two questions from the audience right now. One from Pratme Sharane. I'm sorry, Pratme, if I mess up your name. He actually asks, how can we build an AR application using Unity and Firebase, such that we could load 3D models from the cloud at runtime? Do you see the question as well?
So yeah, thanks for showing that. So exactly as we described in the second part of the workshop. You download the SDK, you integrate that into Unity, and automatically Unity is cloud connected. You don't even have to use Firebase automatically. You can just use our database, and you're good to go. Like we saw in the demo, all you have to do is just embed the SDK, and that's it. Like you have an app that's automatically cloud connected, and you can start streaming data as easily as pressing play. Super, super simple.
Yeah, I can imagine people just sometimes having missed a few things because there was so much to see. He actually has another question. Is it mandatory to use AR Foundation to create an AR app using Unity and ARCore?
So not at all. I mean, you can use any kind of AR SDK that you want. You can use WebXR. You can use Vuforia, VisionLeap. There's so many kind of AR SDKs out there that you're welcome to use with Unity and Echo AR. From our perspective, we're just streaming the data to your camera SDK of choice. I definitely recommend AR Foundation if you use Unity because it's really robust and allows you to kind of build for iOS and Android at the same time. But you don't have to do that. You can use anything you want. Again, Vuforia, there's so many options out there. Kind of feel free to use whatever.
I have a few questions of myself. Let's see, where did I leave them? Yeah, something you showed a bit, but I must admit it went a bit too fast. If I want to add interactivity, you could use these, you added these behaviors where you can read data and generate stuff from that. But if, for instance, I want to tap an object or I want to move it, how would you go about, because downloading models from the cloud, I can understand. Adding interactivity to it is always hard then. So how do you go about that?
Great question. So in the kind of web or sample apps, all of these like interactions are already baked in. So moving, rotation, scale, everything works. And in Unity, specifically in our scripts, like you're only limited to your imagination. Like you can add anything you want. We have demo scripts and open source examples. Just adding the script that allows you to tap, click, do whatever you want. And then you can also kind of, once you have that kind of interaction built in, you can also control what happens. So let's say if you click a model, it redirects to a website. So you bake in that feature, but then you can decide which website will it redirect with through the cloud. You just add that URL there, and tomorrow you want to have, let's say you're building applications for retailers or for some clients, and you want when every time you click a model, it redirects to their website. Perfect. And now you can build that app again and again and again with different clients, but all you have to do is just switch that URL in Echo AR, and you're good to go. So it's super easy, and it's, again, like you can bake any kind of feature that you want into Unity specifically, and just kind of control the behavior through Echo AR.
Yeah, I specifically was interested in Unity because that is a little bit my thing. I work on HoloLens. I check if I get any more questions. Yeah. So, and one of the things, downloading stuff for HoloLens is specifically the things what we're looking at. Having said that, is there a limit to the size of the models you do? Are we talking kilobytes, megabytes?
So it depends on the kind of tier that you're choosing at Echo AR. We have different tiers and different prices around kind of how much bandwidth and storage you can have, but there's no limit on the size of the model. We had clients sending us files that are like 500 megabytes.
Oh, that's more than enough.
Yeah, but the cool thing about our Echo AR is, like, under the hood, we're actually taking that 500 megabytes, when converting it and compressing it to be 5 megabytes, and then we're streaming that. So a lot of, like, again, like the kind of the power of the cloud here is the kind of compression and conversion on the cloud. If you saw in the console, I uploaded an OBJ file, and automatically I got a USDZ, GLTF, and FBX files kind of as well, because under the hood, our platform automatically kind of converted all these 3D files to all the different other formats to make sure it will work, again, in Android, iOS, MagicLeap, HoloLens. Because, for example, iOS really likes USDZ files, but HoloLens likes like OBJs, and Unity likes GLTF and stuff like that. So a lot of these things are kind of happening under the hood, and all these optimizations kind of happen automatically.
Yeah, I was also you couldn't see that, of course, because my camera was off, but I was actually playing around with you when you showed the QR codes. I was putting the apartment here in my model, and the thing that came out of the screen also worked. It was very nice to see.
That's another good point, that under the hood, there's a lot of optimizations when it comes to performance. So when you, because we're in different kind of geographic locations, when I opened the application, like, it actually streams from a server in like North America. when you stream it, like wherever you are, let's say you're in Japan or in Australia, it will automatically stream it. There you go. So it will send, like when you stream it, it actually sends you that data from a server physically closer to you to kind of make sure that the stream is like the fastest that it could be. And again, everything is kind of invisible to you, but that's again the power of the cloud.
Yeah, actually, the longest part of the process of getting the model in my apartment was reading the QR code. Yeah. Something so you answered my next one. You can embed this in existing applications I've seen. Can you also, you used QR codes, and then it would, like you said, it went a bit fast. Can you also recognize 3D objects and use them as a marker like Vuforia does?
Yeah, so 100% yes.
Unbelievable.
You just stream the data. Like if Vuforia has the capability, or Visionly has like these capabilities of model tracking, use that. We actually have an example on our GitHub for model tracking. So you can, like, it's open source, you can just take that as is. But from our perspective, it's all about just like streaming data and making sure that your application is kind of dynamic. So like after you use Vuforia or whatever, what now? Like what do you want to do? So let's say you want to overlay a toy car with a 3D car.
Exactly that. For instance.
Model, but now with Echo AR, you can choose which car, and tomorrow you can switch the color of the car, or switch the car to a building, and the building to I don't know, an animal or whatever. But the point is, like, you can build your application once and then change that remotely through Echo
AR. Something I find, we are also a very but not also a very common scenario is that you have some kind of intermittent connection to the cloud. Is it possible to have your Echo AR download the models and cache them locally while I walk out of Wi-Fi range, or doesn't that work? Or maybe store them locally?
Yeah, so it really depends on which SDK you're using. Some of them do support caching, some don't. But Unity. In general, like we do definitely recommend that you kind of connect to the cloud as much as you can, just because that we see a lot of people that if you have an app that is really large, specifically in the AR VR space, it kind of detracts people from downloading it. We worked with a company, for example, that had like a really, really compelling AR app, but that app was like almost like 1 gigabyte. And like every time you want to add new content to it, it will just add more and more because like they would use Unity, and that would just kind of explode their build to be this insane monstrosity. And every time you want to like onboard a client or like even like upload it back to the App Store or Play Store, you get to the point, like, it's like people just don't want to download that anymore. And that's why, again, the powerful cloud is so important, because that means your app is still super, super small and the data kind of comes in from the cloud. But definitely there are kind of, depending on the SDK, you definitely have some caching capability.
Well, since this is a non-profit, I won't ask you about the money stuff, because I assume that will be able to find on your website.
Yeah. There's also a very generous free tier. So like everything I showed you right now, you can do for free. Just play around with it and kind of follow our documentation.
We Dutchies say you're mowing the grass before my feet, because my next question was, do you have a trial version? Well, that apparently is the case.
There you go. Yeah.
All right. Yeah, I must say I'm very impressed. I think unless you have, there are no more questions. Unless you have something to add, I think I will just wrap it up. Thank you very, very much for your time. If you have to say one more last thing to the viewers, go ahead. If not, then thank you.
Everyone stay safe, healthy, and sane. Jose, thank you so much for moderating this. Did a fantastic job, and for all the team in Global XR Bootcamp for like running this fantastic event. And kind of really thank you for connecting everyone in these weird times. I think, again, as I said earlier, this is the time for AR VR. This is the time to build applications at scale. And I think, again, this community is well positioned to kind of bring in kind of new applications that a few years ago were almost like unimaginable. So thank you so much, everyone, and specifically for you, Jose.
I couldn't agree with you more. Thank you. Bye-bye. Cheers.